If we take a look at example 6 here, it says, Lelania and Helena work part-time at a smoothie store. The number of hours they worked increases for the first 5 weeks on the job. The graph models Melania's weekly earnings and the table models Helena's weekly earnings for these 5 weeks. State whether each relation is a linear function. Explain. Well, if we take a look at Melania's earnings, see how that's a nice line? So if it graphs to a line, that's linear. Now when I look at a table, I have to look at a couple things. It's got to be linear. It's got to grow at a constant rate. Notice Helena's weeks go 1, 2, 3, 4, 5. So the x's grow by the same amount, or the independent variable grows by the same amount. Let's look at the dependent variable. From 60 to, whoops, need a graph there, a pen. 60 to 120, it grows by 60. 120 to 180, it grows by 60. Looks pretty good so far. Uh-oh. 180 to 210, it grows by 30. This is nonlinear. Nonlinear means it does not grow by the same amount each time. Line symmetry. Now we're going to go and look at graphs that are pretty much nonlinear. Line symmetry is exactly what it sounds like symmetry from biology. That is, you have a line that runs through the graph, an imaginary line that you could run through the graph. You could fold the graph over, and every point would match over. So we're going to have two equal halves. Now, if I look at example 7, is there a line that I could draw through that would match it perfectly? Well, let me change colors here so you can see it. It looks like the y-axis would be a line of symmetry, doesn't it? That is, I could take it and I could flip it over the y-axis. It would match up perfectly. So this is line symmetry.